The calcium carbonate, which is upon decomposition, it gives a calcium oxide and carbon dioxide. In beginning, the velocity of the forward reaction will be V is a maximum and the velocity of the backward reaction is 0. Divide the molar concentration of the reactant divided by molar concentration of the product by considering a new terminology that is known as equilibrium constant, that is Kc. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with a unit called equilibrium. Under this unit, we have understand with the concepts of introduction to the equilibrium, and also we have learnt about the classification of equilibrium, and we have understood about the physical equilibrium and its different types in the equilibrium in the physical processes. And also, more interestingly, we have understood the equilibrium which involves the dissolution of solid or gases in the solvent, so that is in the liquid. And also, we have learned about the general characteristics of physical equilibrium processes. Today, let us move on to the next topic of this unit by understanding the equilibria of chemical reactions and the equilibrium in chemical processes and the characteristics of chemical equilibrium and types of chemical equilibrium and the law of mass action we are going to understand in this session. So, firstly, we will see the equilibria of chemical reactions. So, already we have understood that the equilibrium, it is nothing but a state of existence of two opposing forces which are attaining simultaneously. That is said to be equilibrium. Okay, and already we have understood that the equilibrium of a chemical reactions will be taking place in a two way. One is a reversible reaction and the one is irreversible reaction. If I say it is a reversible reaction, remember we can reverse the reactant is giving rise to the product. The meanwhile the product can also giving rise to the reactant. Hence such reactions are said to be reversible reaction. You can take the example of calcium carbonate. The calcium carbonate which is upon decomposition, it gives a calcium oxide and carbon dioxide. Similarly, if you don't allow this carbon dioxide to evaporate in the entire vessels, calcium oxide can react with the carbon dioxide simultaneously and giving back to the calcium carbonate. Hence, it is an example for reversible reaction. Okay. We have one more example, that is nitrogen and hydrogen can react themselves to give ammonia, and ammonia themselves can give rise to the separate of hydrogen and nitrogen. We have one more reaction, that is an irreversible reaction where only the reactant is giving rise to the product, only it is in a forward direction, there is no backward reaction we cannot expect from this reaction. Hence, it is known as what? Irreversible reaction. The best example is magnesium oxide formation, where the magnesium can react with an oxygen to form a magnesium oxide. Remember, the magnesium oxide cannot come back to the virginal state of magnesium and oxygen. Okay, this is how the equilibrium in the chemical reactions can be understood by understanding only the two types of reaction. One is reversible reaction and the one is irreversible reaction. Next, the equilibrium in chemical processes. I will consider the reaction, okay, A plus B is giving rise to C plus D. Okay. Now, at a time 0, okay, at a time 0, the molar concentration, or you can say that the concentration of the reactant is very high. Correct? No, at the initial stage, the reactant concentration will be very high and the product concentration will be almost 0. Correct? No, at the initial stage, at a time 0. After when a time passes to 10 minutes or 1 hour like that, the concentration of the reactant will be increased, but the concentration of the product formation will be at a particular stage, at a particular point of instant, the state of rate of concentration of the reactant will be equal to the rate of formation of the product. We call such two opposing forces which is happening simultaneously as a equilibrium. Since we are studying about the chemical reaction, we say it is a attainment of the equilibrium in a chemical processes. You can understand this by looking at this diagram. So here I have a graph of a concentration versus time. You can see that I have considered the two reactant A plus B. At the initial stage, the concentration of the reactant will be very high. Correct now? You can say that we have one more graph for the product. You can see that at a time 0, the concentration of the product is very 0. As the time passes, the concentration of the product will be increased. But as the time passes, you can see that the concentration of the reactant is decreasing. Okay, at particular time, you can see that the rate of formation of the reactant will be equal to the rate of formation of the product. We call the stage as a equilibrium state. We call that what as equilibrium. So, this is an attainment of the equilibrium in a chemical processes. So, hope you all understood. Remember, I am considering the two reactant A plus B is giving rise to C plus D. Okay, and this at a time 0, if I consider, you can see that the concentration of the reactant is very high. That is A plus B is very high. As the time passes, it is decreasing. You can see that similarly with the product, at a time 0, the concentration of the C plus D will be completely 0 only. Correct now? And it is decreasing. As the time passes, it is started increasing. At a particular point, the rate of concentration of the reactant will be equal to the rate of concentration of the product. Hence, such state are known as equilibrium state. As the reaction proceeds, you can see that let us consider the reversible reaction. A plus B is giving rise to C plus D was conducted in a closed vessel at constant temperature. In beginning, the velocity of the forward reaction will be V is a maximum and the velocity of the backward reaction is 0. As the reaction proceeds, the velocity of the forward reaction go on decreases, but the velocity of the backward reaction will be increases. After some time, at a particular instant of time, the velocity of the forward reaction will be equal to the velocity of the backward reaction. That state we call it as what? The state of chemical equilibrium or equilibrium. Okay. Next, we will see the characteristics of chemical equilibrium. As we have understood that at particular instant of time, the two opposing processes which are attaining simultaneously, such processes are called as what? Equilibrium. Since we are dealing with a chemical reaction, hence we can say that the chemical equilibrium are dynamic in nature. And at equilibrium, the concentration does not change with the time. The concentration will not alter. Only the processes, two opposing forces are attaining. Okay. And the catalyst has no effect on the position of the equilibrium because it alters the both. The forward and the backward reaction to the same extent, but the equilibrium attains quickly. If you take in catalyst, it does not have any effect with the equilibrium, but it can also affect to the forward and backward reaction. The position of the equilibrium can be disturbed by varying the pressure, temperature as well as with the concentration, and it is applicable only when the concentration of the reactant and product are attain the constant value. Okay, and it is independent of initial concentration of the reactant and the product, but it depends upon the temperature. The equilibrium constant for the reversible reaction is inverse of the equilibrium constant of the forward reaction. If the equation is multiplied and dividing, the constant values are also equal to its respective powers or to their respective roots. So, by this it's clearly understood that the chemical equilibrium is a dynamic processes and the catalyst has no effect towards the equilibrium processes, and it does not depend upon the initial concentration as well as with the final concentration. Next, we have the types of chemical equilibrium. There are two types of chemical equilibrium will be there. One is homogeneous equilibrium and the one is heterogeneous equilibrium. Homogeneous in the sense, if the equilibriums are said to be homogeneous, the reactant as well as the product should be present at the same phase. Such equilibriums are said to be homogeneous equilibrium. The example is, you can see that hydrogen and iodine are combined together to form a hydrogen iodide. You can see that both the reactants are present in a gaseous state, whereas our product is also in the gaseous state. Such reactions are said to be homogeneous chemical equilibrium. Okay, we have one more reaction, that is nitrogen and hydrogen are combined to form ammonia, where nitrogen and hydrogen are gases, whereas our product is also gases. Okay, similarly we will see with the heterogeneous equilibrium. The equilibrium is said to be heterogeneous only when the reactant as well as the product will be present in a different phases. Such equilibriums are said to be hetero. Hetero means different. Okay. We'll take up the example of calcium carbonate only. The calcium carbonate is a solid. During the decomposition, it decomposes to give a calcium oxide and a carbon dioxide. Carbon dioxide is a gas, whereas the calcium oxide is a solid. You can see that this is my reactant which is present in a solid state, whereas my product is present in a different phases. That is, one is present in solid state and the one is present in the gaseous state. Similarly, we have one more example of NH4HS, which is decomposes to give ammonia as well as with a hydrogen sulfide gas. You can see that this is a gas, whereas our reactant is a solid. Like this, the types of chemical equilibrium can also be understood if it is an homogeneous or if it is an heterogeneous. The differences between these two can also be asked with the 2 marks, and it is very, very important for the examination point of view. So, they can ask you to write what is a homogeneous equilibrium, give an example, or what is heterogeneous equilibrium with a given example, or sometimes they can ask you to distinguish between the homogeneous and heterogeneous equilibrium with a one proper example. You must know with this definition. Next, we have laws of mass action, which is also known as what? Law of equation. First, we will see what is the law of mass action we will tell about, and how to derive the equations with the expression that how to derive an equilibrium constant, that is Kc, we will see later. Okay. According to the law of mass action, it states that the rate of the reaction is directly proportional to the product of the active masses of the reactants at a constant temperature. So, it is a rate of the reactions which is directly proportional to the product of the active masses of the reactant at constant temperature. That is said to be what? Law of mass action. So, based on this law, you can derive an expression for the equilibrium constant, that is Kc. We'll see how to derive this equation now. Okay. I'll consider a reversible reaction where A plus B is giving rise to C plus D. The small a, small b, small c and small d are nothing but a stoichiometric coefficient. They are nothing but a numbers. Okay. Whereas capital letter A and B are the reactant. The capital letter C and D are my product. Okay. Now, A plus B is giving rise to C plus D is conducted in a closed vessel at constant temperature. Let the molar concentration of the A, B, C and D are known as what? Molar concentration of the reactant as well as with the molar concentration of the product respectively. Let RF and RF be the velocity of forward reaction and velocity of the backward reaction respectively. What is the RF and RB stand for? RF means reactions which is taking place in a forward direction. That is, A plus B is giving rise to C plus D. It is an RB in the sense C plus D is giving rise to A plus B. Okay. So, this is known as what? A forward velocity of the forward reaction as well as with the velocity of the backward reaction. Now, I'll apply the law of mass action to the above equation, that is to the forward reaction I'll apply now. Okay. So, RF is directly proportional to the molar concentration of the reactant A into the molar concentration of the reactant B. So, what does this small a and small b stands for? Again, it is a stoichiometric coefficient. It is nothing but a numbers. Okay. Now, in order to remove this proportionality constant, I will put RF is equal to Kf into molar concentration of the reactant A into molar concentration of the reactant B raised to the power B. Only I have applied what? A law of mass action for the forward reaction. Now, already we have know that Kf is nothing but what? Velocity of the forward reaction. Okay. Now, I will apply the laws of mass action to the backward reaction. So, what is the backward reaction says? Rb is directly proportional to the molar concentration of the product C and the molar concentration of the product D raised to the power D. In order to remove this proportionality constant, I will put Kb. Kb is nothing but a velocity of the backward reaction. Okay. So, Rb which is equal to Kb into molar concentration of the C to the power C and molar concentration of the D to the power D. Now, we know that at a particular point of time, the rate of forward reactions will be equal to the rate of backward reaction, or the rate of molar concentration of the reactant will be equal to the rate of the backward reaction, that is equal to the molar concentration of the product. So, I will consider the reactions of the forward directions will be equal to the reactions at a backward direction. So, we know that what is the RF now, correct now? So, RF will be equal to Kf into molar concentration of the A to the power A and molar concentration of the B to the power B. Similarly, we know that what is the Rb also for the backward reaction, that is Kb into molar concentration of the C to the power C and molar concentration of the D to the power D. So, I will put the values for Kf and Rb now. Now, I can divide the molar concentration of the reactant divided by molar concentration of the product by considering the new terminology that is known as equilibrium constant, that is Kc. So, Kc which is equal to Kf divided by Kb which is equal to concentration of the product divided by concentration of the reactant. So, Kc is nothing but the equilibrium constant and it is expressed in terms of molar concentration. The equilibrium constant is the ratio of velocity constant of the forward reaction divided by velocity constant of the backward reaction, and you can define it in this way also. So, equilibrium constant, it is nothing but a ratio of the reactant divided by ratio of the product. So, or you can say that the equilibrium constant is nothing but a ratio of molar concentration of the reactant divided by molar concentration of the product divided by molar concentration of the reactant. This is how the equilibrium constant Kc derivation can be derived by taking up an reversible reaction. So, hope you understood this derivation. Okay. Sometime in the exam they will give a reaction, we need to apply this equilibrium constant, that is law of mass action, and we need to write up the Kc value for that. We will take up the 3 examples and we will understand how to write. Here I have a reaction, nitrogen and hydrogen are the reactant which is combined to form a product, that is ammonia. For this, how to write the Kc value, that is nothing but a equilibrium constant. We know that the Kc is nothing but a concentration of the product divided by concentration of the reactant. Here you can see that ammonia will be present in the power 2, whereas the nitrogen is nothing and hydrogen which is having to raise to the power of 3. We have one more reaction, that is PCl5 which is undergo decomposition to give a PCl3 plus Cl2. Correct now? So, that is phosphorus pentachloride. For that, if you wanted to write the Kc value, that is, it is a product, the molar concentration of the product divided by molar concentration of the reactant. Similarly, we have one more reaction, that is hydrogen and iodine are combined to form a hydrogen iodide. The Kc value for this is Hi, because 2 Hi will be there. So, the molar concentration of the Hi into the raised to the power 2 divided by molar concentration of the H2 as well as with the I2. This is how the Kc value, that is equilibrium constant value, can be written for the given reaction. It is a ratio of molar concentration of the product divided by molar concentration of the reactant. So in our next class, we are going to derive one more equation, that is Kp, expression for the gaseous reversible homogeneous reactions. By this, hope you all understood with this session. In this session, what are all things which I covered? Again, it is an important for the examination point of view. Have a look on it. I'll come back with the next session. Till then, take care. Peace. Thank you.